Hello girls, to continue with the nitric acid chapter, today we are going to start with the chemical properties. Now, how stable is nitric acid? Now, pure nitric acid is unstable to heat or sunlight. It easily decomposes to give yellow solution due to the formation of nitrogen dioxide. So 100% nitric acid is not used because pure nitric acid, it decomposes, okay, when heat is given or in the presence of sunlight to give nitrogen dioxide. You know the color of nitrogen dioxide is reddish brown fumes, water and oxygen. And in the presence of sunlight, nitric acid decomposes even at room temperature, that is normal temperature. The nitric acid stored in a bottle turns yellow. So explain why, give reasons why. Nitric acid stored in a bottle turns yellow. What is your answer? It will decompose in sunlight, and this color is due to the dissolved nitrogen dioxide in nitric acid. So to avoid this decomposition, nitric acid is normally stored in colored bottles. So either you'll get the nitric acid stored in a bottle turns yellow, or why, explain why, give reasons. Nitric acid is stored in colored bottles. Now next we come to the acidic properties. Nitric acid is a very strong monobasic acid. That means nitric acid ionizes almost completely. It completely forms ions. No molecules remain behind in aqueous solution, and it forms hydrogen ions and nitrate ions. Since it is acidic, you know it turns blue litmus red, methyl orange pink, phenolphthalein remains colorless. And now reaction with alkalis, since it is an acid, it neutralizes. Neutralization reaction takes place with alkalis to form salt and water only. Okay, so all these equations, your assignment for today is to write down all these equations and submit it as usual day after tomorrow. Okay, so all metallic oxides and hydroxides react with dilute nitric acid to form their respective soluble metallic nitrates and water only, salt and water only. So the salt is in the form of nitrates since these bases are reacting with nitric acid. So here you can see potassium oxide, copper oxide, zinc oxide, sodium hydroxide, iron hydroxide, this is ferrous hydroxide, magnesium hydroxide with nitric acid will give their respective salts. You can see potassium nitrate, copper nitrate, zinc nitrate, sodium nitrate, okay, and ferric nitrate, magnesium nitrate, and water only. Please learn these equations. Now you know chemistry means only equations. Now reactions with carbonates and bicarbonates. It reacts with carbonates and bicarbonates. Apart from the salt form, you know, carbonates, bicarbonates, a gas is released, carbon dioxide gas is released. So with calcium carbonate, sodium bicarbonate, sodium carbonate, copper carbonate, and with nitric acid, it will form the respective salts. Nitrates, of course, calcium nitrate or sodium nitrate or copper nitrate. Water together with the evolution of carbon dioxide gas. Okay, that is its reaction with carbonates. And action with metallic sulfites and bisulfites. Now sulfites means which gas will be released? Sulfur dioxide. So metallic sulfites and bisulfites react with dilute nitric acid to form their respective metallic nitrates. So nitrates are formed. Now potassium sulfite, copper sulfite or calcium bisulfite with nitric acid will give their respective metallic nitrate, potassium nitrate, copper nitrate, calcium nitrate. Water and sulfur dioxide gas will be released. Now next, coming to the oxidizing properties, nitric acid vigorously oxidizes non-metals, metals, inorganic compounds and organic substances, that is addition of oxygen. Now nitric acid itself undergoes reduction. Since it is oxidizes other compounds, it will become reduced to form different reduction products like nitric oxide, nitrogen dioxide, nitrous oxide. Okay, so these products depend on the acid concentration and the temperature of the reaction. So what is produced depends on the concentration of the acid and the temperature of the reaction. The oxidizing properties of nitric acid is due to nascent oxygen. Nascent oxygen means one atom of oxygen. Okay, but once nitric acid decomposes, nascent oxygen, one atom of oxygen is released, which is responsible for the oxidizing properties. So here you can see where concentrated nitric acid or dilute nitric acid produces nitrogen dioxide, water and nascent oxygen. If it is dilute, 3 atoms of nascent oxygen. Now nitric acid is a very powerful oxidizing agent, and the nascent oxygen is responsible for oxidizing hydrogen to water. Now action on non-metals. Non-metals like carbon and sulfur is acted upon by concentrated nitric acid to form, if it is carbon, then carbon dioxide, water and nitrogen dioxide gas will be given off. You know, nitrogen dioxide is reddish brown fumes. Okay, and with sulfur it forms sulfuric acid, water and again nitrogen dioxide gas. Now action on metals. Nitric acid reacts with all metals except gold and platinum. Now the action of nitric acid on metals depends on the temperature again and concentration of the acid. Now if the acid is cold and dilute, that means lots of water is added, it oxidizes metals to their nitrates and nitric oxide is liberated. So when we use on copper, the action of nitric acid, cold and dilute nitric acid on copper, zinc and iron, copper nitrate, zinc nitrate, ferrous nitrate, water and nitric oxide is released. But again, if we use concentrated nitric acid, or if the acid is dilute, then it is hot. Okay, hot and dilute. This you must keep in mind. Okay, children. One, remember here is cold and dilute nitric acid, and what is released? Nitric oxide. Okay, and in this case, nitrogen dioxide when the acid is concentrated, or even if the acid is dilute, it must be heated. It must be hot. Okay, so there is a difference in what is released out. So here in this case, copper, zinc and iron will react with nitric acid, concentrated nitric acid, or hot and dilute nitric acid to give copper nitrate, water, or zinc nitrate, water, or ferrous nitrate and water together with nitrogen dioxide, brown fumes of nitrogen dioxide gas. And there are metals like iron, aluminium, cobalt and nickel. They become passive or inert when treated with pure concentrated nitric acid. This is important. Explain why. It is due to the formation of extremely thin layer. Now if the reaction is taking place and there is a barrier formed, then the reaction will stop. So here a barrier is formed of an insoluble metallic oxide, which stops the reaction, because the acid will not come in contact with the metal, because there is a metallic oxide formed in between, and the acid will not react with the metallic oxide. So the reaction will stop. So this passivity can be removed by rubbing the surface layer with sandpaper or by treating with strong reducing agent, so that the oxide layer can be removed. Okay. Now please remember, children, that dilute nitric acid is considered a typical acid except for its reaction with metals, since it does not liberate hydrogen. It is a very powerful oxidizing agent, and the nascent oxygen formed is responsible for its oxidizing properties. Now very dilute acid, only about 1% acid, reacts with magnesium and manganese at room temperature. Okay, otherwise other acids does not react with magnesium and manganese. Okay, only very dilute, about 1% acid reacts at room temperature to give their nitrates and hydrogen gas, because here I just told you that it does not liberate hydrogen. But there is an exception. When we take very dilute acid, about 1%, then hydrogen can be released, because the oxidizing agent of the acid is much reduced due to dilution, because nitric acid can oxidize. That is why hydrogen cannot be formed, because hydrogen will be oxidized by the nascent oxygen to form water. That is why it is very difficult to release hydrogen using nitric acid. But very dilute, very dilute nitric acid with magnesium or manganese, okay, it can release hydrogen, because I told you the oxidizing agent of the acid is reduced due to dilution. That is, lots of water is added to the acid. So these reaction prove that nitric acid contains hydrogen. All acid must contain hydrogen. Now reaction as aqua regia, we did that when we did hydrochloric acid. If you remember, concentrated nitric acid 1 part by volume, when mixed with concentrated hydrochloric acid 3 parts by volume. The ratio is 1:3, gives a mixture called aqua regia, which means royal water. I think if I remember, I had mentioned to you when I was doing this chapter in the class. I think we did that in the class, that there are certain cheats coming and saying that we are going to clean up your gold and platinum ornaments, and they will put it in a solution, take it out, and then there you have your gold chain shining and bright, and you are so thrilled. But when you go and take the weight, you'll see that it has reduced. Why? Because the gold dissolves in aqua regia. So the solution they're carrying is aqua regia. So when one layer of the gold dissolves in the solution, what remains back? Sparkling gold remains back, shiny gold. So if those people go from at least to 10 or 20 or maybe 100 houses and clean the gold, so just imagine how much of gold they will collect at the end of the day. Okay, so nitric acid and concentrated hydrochloric acid ratio 1:3 will form nitrosyl chloride, water, and nascent chlorine. Okay, now nitric acid oxidizes hydrochloric acid to chlorine. Okay, so this mixture aqua regia reacts even with noble metals like gold and platinum to give their chlorides. So aqua regia contains nascent chlorine which attacks these metals. So it is this chlorine which goes and attacks gold and platinum, the most expensive metals, isn't it? So here you can see platinum and gold is being reacted upon by the nascent chlorine to form platinum chloride and gold chloride. So they can easily extract these metals from their chlorides. Okay, now we will move on to the uses of nitric acid. Now here in the uses of nitric acid, children, please remember, they will ask you why, explain why, give reasons why nitric acid is used to etch designs on copper and brassware. Because you know that nitric acid dissolves almost all metals. It is a solvent for a large number of metals except the noble gases. Okay, then why is it used to purify gold again? Gold contains impurities like copper, silver, zinc, lead, and these metals dissolve in nitric acid. Okay, next uses, it acts as a rocket fuel oxidant, and it is also used in the preparation of fertilizers like calcium nitrate, ammonium nitrate, nitro chalk, basic calcium nitrate, and of course I just told you in the preparation of aqua regia, which dissolves noble metals. In the industry, it is used in the manufacture of explosive like TNT, synthetic fibers like artificial silk, nylon, celluloid, plastics, photographic films, and important compounds like nitrates of potassium, ammonia, silver is also manufactured using nitric acid, and even in the manufacture of dyes, drugs, and perfumes. Okay, now what are the tests for nitric acid and nitrates? Now first is the brown fumes. When it is heated, brown fumes are of nitrogen dioxide. Okay, then next, nitrates other than potassium, sodium, and ammonium produces reddish brown fumes of nitrogen dioxide. So metallic nitrate, when heated, metal oxide, and the reddish brown fumes proves that It is a nitrate, sorry. Now on adding copper to nitric acid or acidified nitrates, dense reddish brown fumes of again nitrogen dioxide are evolved. So that is the main test for nitrates or nitric acid. Now this brown ring test is very important. If we were in school, we would have done it in the lab. Now what to do, like maybe if you take up science, you might be doing in your class 11. So the procedure is, to the aqueous solution of nitrate or nitric acid, we add freshly prepared saturated solution of iron to sulfate. Now after that we add concentrated sulfuric acid carefully from the sides of the test tube, very carefully. It should trickle down through the side of the test tube so that it should not fall dropwise. If it falls dropwise on the test tube, it will disturb this whole thing, so that shouldn't be disturbed. Okay, so from the side it is poured so that it just slowly slips down the side of the test tube. Okay, so we cool the test tube in water, and then you'll see some magic. A brown ring appears at the junction of the two liquids. Here you'll see a brown colored ring. Okay, so this is known as the brown ring test. So this is the reaction taking place. Okay, the brown ring is nitrosoferrous sulfate, which is a brown colored compound, and you'll find it between the two liquids. Okay, and remember children, why is freshly prepared ferrous sulfate solution used? Because on exposure to the atmosphere, it oxidizes to ferric sulfate, and then you will not get the brown ring. The brown ring of nitrosoferrous sulfate is formed at the junction of the two liquids, so it separates the two liquids. The concentrated sulfuric acid being heavier, so you have H2SO4, it is heavier and it settles down, and ferrous sulfate is lighter and it remains above the brown ring, resulting in the formation of brown ring at the junction. Now the brown ring of nitrosoferrous sulfate decomposes on disturbing the test tube. So if you shake the test tube slightly, the brown ring will disappear. Okay, and even because the heat is evolved which decompose the unstable brown ring. The brown ring is unstable. Now quickly let's take a look at the effects of heat on nitrates. Sodium nitrate and potassium nitrate, when heated, it will turn into sodium nitrite, potassium nitrite, and oxygen gas will be given out. Now you know how to test for oxygen. A glowing splinter is brought nearby which will immediately burst into flames. Okay, all other nitrates except those of silver and mercury, all nitrates, exception is silver nitrate and mercuric nitrate, they decompose. Silver and mercuric nitrate do not decompose, but other nitrates decompose to their oxides, nitrogen dioxide and oxygen. Okay, there you can see calcium nitrate on heating, calcium oxide. Calcium nitrate is colorless and crystalline, and it gives a white colored solid, a reddish brown gas. These are all observation children, very important. And oxygen, which in which a glowing splinter bursts into flame. Okay, zinc nitrate, it slightly decrepitates, that sound, a crackling sound. Okay, it is very deliquescent and forms zinc oxide. Zinc oxide is yellow when hot, white when cold, and of course reddish brown fume, and oxygen which rekindles a glowing splinter. Lead nitrate again decrepitates on heating. Okay, it will start making that sound, crackling sound. It is again colorless and crystalline. These observations are very, very important children. And it is a yellow solid which fuses with the glass. That means it sticks to the glass. Then nitrogen dioxide and oxygen. I've been already telling you, nitrogen dioxide, reddish brown fumes, and oxygen rekindles a glowing splinter. Copper nitrate, it is blue and crystalline, turns into black copper oxide, nitrogen dioxide and oxygen. Silver and mercury nitrates are white and corrosive, means they can easily corrode, which decompose into their respective metals, nitrogen dioxide and oxygen. So we have silver nitrate, which is white in color. It is corrosive. When heated, will give silver gray colored silver. nitrogen dioxide, reddish brown fumes, and oxygen, which rekindles a glowing splinter. Mercuric nitrate, it is again white and crystalline and turns into a silver mirror, shiny. Nitrogen dioxide and oxygen. Ammonium nitrate decomposes explosively, okay, violent reaction, leaving behind no residue. No residue, everything will go off, it will vaporize off. So when ammonium nitrate is heated, laughing gas, nitrous oxide is also known as laughing gas, is produced and water vapor is produced. So the solid will explosively like in heat, it will decompose explosively and nothing is left behind. Okay, so with this, children, we come to the end of this chapter. So I've already told you what to do for your assignment. Till then, children, stay safe. God bless you.